This will be review of things that you learned in Algebra 1, but we're going to quickly go through it. So section 7.1, part 1 is on ratios and proportions. So a ratio, it says if A and B are two quantities measured in the same units, the ratio of A to B is A to B, sometimes written as A over B. In order to compare two numbers, you must make sure that they have the same units. Okay, so this way the units cancel each other out. Okay, so that might not make very much sense, but if you think about like 39 centimeters over 13 meters, think about which of those quantities is bigger. Is the 39 centimeters, is that distance? Kind of show me with your hands how much 39 centimeters would be. So 100 centimeters is like this big, like a meter stick. So 39 is like that big. Think about 13 meters. Can you show me with your arms what 13 meters looks like? No, it's pretty long, isn't it? So 13 meters. I don't know, probably longer than this actual classroom. So which one's bigger? The 13 meters. Okay, so that's why you have to get them to be the same units. So what we're going to do is we're going to change the centimeters into meters, or we're going to change the meters into centimeters. Okay, so I feel like it's probably easiest to take the bigger item, so like meters is bigger than centimeters, that way you don't have to deal with decimals. So what can I change 1 meter into? How many centimeters? 100, right? Centa. Like cents, century means 100. So we're going to fill this with 100 centimeters. So if I have 13 meters, then how many centimeters do I have total? Yeah, 1,300, right? So then once you have the units are the same thing, you're able to just cancel those units out. So centimeters over centimeters, those centimeters go away. So now we take our 39 over 1,300. And you can do that on your calculator. I don't know if I've talked about the fraction button. It's my fave. So when I do 39 divided by 1,300, I get 0.03 on my calculator. Now I know that that's 3 hundredths, or not 3 hundredths, 3 hundredths. I was saying 3 thousandths, I was thinking. So it's 3 over 100. But I can change it. I can do math and then 1, and it changes it to a fraction. Did you guys know you could do that? So math 1 changes it to 3 over 100. Or you can just reduce things out. So in this case, if you divided by 13 on the top and the bottom, you would get 3 over 100. So 2 yards over 12 feet. So think about yards and feet. Do you guys know how many feet go into a yard? I'm always surprised at how many of you guys don't know this. It's like not taught in school anymore or something. Yeah, so it's 3 feet in 1 yard. So when I talk about 2 yards, I want to talk about how many feet fill that. So how many feet go into 2 yards? It'd be 6, right? Because in each of those yards, we have 3 feet. So we're going to have 6 feet over 12 feet. So when we reduce out feet, we get 6 over 12, which is 1 over 2 is our answer. So these are the ratios. Yeah? Nope, because the centimeters would cancel and the feet would cancel. So you just write the ratio of one thing together. So it's like in the ratio of 1 to 2. Like that one is twice as big as the first one. All right, so I have 0.5 milliliters over 100 liters. So do you guys know how many milliliters are in a liter? You need to know this for chemistry. Are you guys, a lot of you taking chemistry next year? Yeah, so what do you think? 1,000, yep, exactly. Like millennium? So there's 1,000 milliliters is equal to 1 liter. So really, if I want to change it, I want to take this liter and I want to fill it with 1,000 milliliters. So if I have 100, then I'm going to have 100,000 milliliters on the bottom, right? Does that make sense? So I'm going to have 0.5 on top, still in milliliters, and this one is 100,000 milliliters. Does that make sense? So we divide it out, and you can take your 0.5 divided by 100,000. And my calculator gives me it gives it to me in scientific notation. So let's go ahead and let's change this into a fraction. But it doesn't work when I change it into a fraction. So do this along with me on the calculator. I think you'll see what I'm talking about. So when I did 0.5 divided by 100,000, my calculator says 5e negative 6. Okay, so that's another thing that you're going to see a lot when you take like classes like chemistry. So what that means is that e means kind of like exponential form. So it's 5 times 10 raised to the negative 6. That's what that means when there's an e. E means times 10 raised to the. So it's writing it like that. So I don't want to write it like that. I want to write it like a fraction because I want to see what kind of ratio it's in, right? So what we do is if I have like a 0.5 on top, I want to make it into a whole number. Well, I could do that by moving the decimal place over, right? And then moving the decimal place on the bottom over. So I could move it over one place. Like I could go over once and then go over once here. So it would be 5 over 1 million, right? Or I can change it so that it's going to be 1. What do I multiply 0.5 by so that I get 1? Multiply it by 2, right? Does that make it 1? 0.5 times 2. Then I can multiply the bottom one by 2. So this one could also be written as 1 over 200,000. All right, so that's the way you would do that one. Another thing you can do is if you're feeling kind of sneaky, so like you could do things the opposite way. So do you see how I had 0.5 divided by 100,000? So on your calculator, do it the other way. Do 100,000 divided by 0.5. Do you see what you get? You get 200,000, right? That's the reciprocal of your answer. If you do it in the opposite order, does that make sense? Then you would have 1 over that answer. So if you take this one divided by this one, you get 200,000. But since we did that the wrong direction, right, we didn't do the top divided by the bottom, we did the bottom divided by the top, we would do 1 over that answer. Do you guys all understand what I'm talking about? All right, so next up. So it says the perimeter of the rectangle ABCD shown below is 32 inches. The ratio of AB to BC is 3 to 5. Okay, so when we have a ratio of 3 to 5, that means we could have 3, 3, 5, and 5. But does that give me a perimeter of 32? So count it up. So 3 plus 5 is 8, plus another 3 plus 5 is another 8. So we get 16. Did it work? No. So it's been reduced down by something. Do you guys see what it's been reduced down by? By a factor of 2. Did you guys get it? Because we have half of the perimeter that we want. So when we see something like 3 to 5, we just have to know that that's been reduced somehow. It could have been 6 to 10, right? Or 9 to 15. We don't know what it is. So what we do is we rewrite as 3x to 5x. So then we go through here and we can put x's in. So we know, okay, it's been reduced out by some factor of x. This is what we call like an extended ratio. Like you'll see problems that say, write the extended ratio. We put x's in when we do this. So that means our perimeter is going to be 3x plus 5x plus 3x plus 5x, and that perimeter has to equal that 32. So we get 16x equals 32. So that's how we can see that we reduce down by 2, like we were talking about. You guys can all see we reduced down by 2. It's not always as easy as 2, though. Sometimes it's like 1.572. All right, so we have that answer. So then what are the dimensions of the rectangle? Now we go back and we plug in 2 for x. So we have 6, 10, 6, and 10. So our dimensions are 6 inches by 10 inches. We always write dimensions as like length times width, or width times length. It doesn't matter which one you put first. Okay, makes sense? All right, so the extended ratio, that's what I was just talking about. So it says the measures of the angles ABC are in a ratio of measure of angle A to measure of angle B to measure of angle C according to their angle measurements. So for instance, if we had a triangle that was 30, 60, 90, it would be an extended ratio of 30 to 60 to 90, or 1 to 2 to 3 if you reduce it down. So see how I divided everything by 30 to get this. Okay, so we reduce it down. So it says the measures of the angles ABC are in the extended ratio of 1 to 1 to 2. So we're going to rewrite it as 1x to 1x to 2x. Okay, because it's been reduced down by something. That can't possibly be the angle measures. That doesn't make 180 degrees, right? So now we say 1x plus 1x plus 2x has to equal how many degrees are in a triangle? 180, right? So we get 4x equals 180, so x equals 45. We then plug the 45 back in, so I have 45 to 45 to 2 times 45, which is 90. So that's going to be the measures of the angles. So it goes in the order that we talked about it. So we said the measures of the angles in A, B, C. So it's going to be measure of angle A is 45. Measure of angle B is 45. And then measure of angle C is 90. Does that kind of make sense? So you put the x in, you write an equation to solve for x, and then you put the x back into the extended ratio. So it says the measures of the angles in quadrilateral EFGH are in the extended ratio of 2 to 2 to 1 to 1. So we're going to say 2x to 2x to 1x to 1x. So a quadrilateral, do you guys know what a quadrilateral? Think about a basic quadrilateral, like a square. What do the angles in a square add up to be? 360. That's true for any quadrilateral. It always adds up to be 360. So it's not like a triangle where it's 180. We add to 360 for a quadrilateral. So now we can set up our equation. So we can say that 2x added to 2x added to 1x added to 1x has to equal 360. So we have 6x equals 360. So I have x equals 60. Okay, and then we go back in and we plug in. So when we plug in, we get a 120 to 120 to 60 to 60. So those are the measures in EFGH. Okay, so you could say measure of angle E equals 120 and so on. Does that make sense? Do you guys get it? I'll just write it like that. Okay, do you guys get the extended ratio? So you just put an x because you've reduced it down by some kind of factor. All right, so it says sometimes polygons are similar shapes, but they have different sizes. So it's basically like if you could put them right on top of each other, but then one's just scaled smaller, okay? The sides of the polygons could be in a ratio of one to another. So for instance, A, B, C, and D, E, F are in the ratio of 1 to 2. So think about what that means. If it's in the ratio of 1 to 2, yeah, it's twice as big. Now, does that work for sides and angles? Or just sides or just angles? What do we think? Just sides, right? Because the angles can't be in the ratio of 1 to 2, otherwise it would add up to be 360. That doesn't make any sense, right? So just the sides are going to be in that ratio. So if you know that AB is equal to 3, BC is 5, and AC is 4, and we line it up, so we're like, okay, AB is in the ratio of DE. So here's DE. We had AB was 3. If it's in the ratio of 1 to 2, what does DE have to be? It has to be 6, right? Does that make sense? And if we had BC, well, BC is here. It's going to match up with EF. EF's here. If it was 5 for the original, what's this one going to be? 10, right? And then the last one is going to be AC. So first and third letter matches up with first and third letter, DF. So ACDF, it's going to be 8. Does that make sense? You guys see how we do that? So it's kind of similar to what we did with congruent triangles, only now we're scaling it. We're making it smaller or bigger, depending on what we have. Okay, so DE was 6, EF was 10, DF was 8. All right. So it says the ratio of the side lengths of DEF and ABC are in the ratio of 3 to 1. So both triangles are right triangles with the right angles occurring at A and D respectively. AC is 12 and DE is 15. Can you find the missing side lengths? Fill in the values in the triangles below. Okay, so let's match them up. So we have DEF is similar to, so this is a new symbol. We haven't talked about this symbol yet. So it's not congruent. Congruent's different because it has the equal sign underneath, right? So this means similar. So it means it's in the same or it's in a ratio. And it's in the ratio of 3 to 1. So DEF is 3 times bigger than ABC is. So we could also write it as 1 to 3 if we did ABC first. Okay, so let's figure this out. So do you see how AC matches up with DF? Does that make sense based on our picture? AC and DF. Sorry, that's not up there. It's 1 to 3 is what I was trying to write. 1 to 3. So what do you guys think that DF is going to be? It's not really drawn to scale, so it's 36, yeah. Maybe, kind of. All right, so it's going to be 36. Okay, well, let's say we get to go the other way. So what if I had DE and I was trying to go to AB? So DE, AB. 5, yeah. Do you guys all see this? And then we have right triangles, so we can find that missing side. We can find CB by using the quadratic formula. So we say 5 squared plus 12 squared equals x squared. This is another common Pythagorean triple. Do you guys remember the 3, 4, 5 one? This isn't 3, 4, 5. This is a different one, but it's another common one. This is a 5, 12, 13. So x ends up being 13. So you could solve it out, but you'll see it's 13. So then what is EF then? 39, yeah. Makes sense? So we have all the different measurements. So AB was 5, BC was 13, CA was 12, DE was 15, EF was 39, and FG was 36. So we have all of them. Okay, so we've been using what we call a ratio. So a ratio is like a fraction, so it's saying like 3 to 4, 1 to 3, things like that. So a proportion is an equation that relates, or that equates to ratios. So it's an equation. So it's when you have like 1 over 2 equals 3 over x, like something like that. Now some of you guys are going to be really good at doing this in your head. Think about that. If I had 1 over 2 equals 3 over x, what does x have to be? 6, yeah. So some people overthink this and do a lot of the cross multiplication when they don't have to. All right, so it says means. The means are the middle numbers of a proportion. So if I have a to b equals b to c, the means are b and c. And the extremes are the first and last terms of a proportion. So if I have a to b equals c to d, the extremes are a and d. Okay, so the reason we call them the means and the extremes, so look at it. If I have 1 over 2 equals 3 to 6, 1 to 2 equals 3 to 6, the means are the numbers that are kind of in the middle. Those are the middle numbers, 2 and 3, right? The extremes are like the smallest and the biggest. Okay, so means, middle, extremes, smallest and biggest. Okay. All right. So the cross product property. So it says the product of the means equals the product of the extremes. Okay, so I'm pretty sure you guys have seen this, but if you have something like 2 over 5 equals 4 over 10, if I take these two numbers and multiply them, what do I get when I take those two numbers and multiply them? 2 and 10, 20. What about if I take these two numbers and multiply them? 20. So 20 is equal to 20. So 2 times 10 is equal to 4 times 5. So that's called cross multiplication, right? And the reciprocal property. So it says if two ratios are equal, then their reciprocals are also equal. So if I have like 1 over 2 equals 3 over 6, like I was talking about, doesn't that also mean that 2 over 1 is the same as 6 over 3? Can't I flip them both over? And it's the same. Yeah. So 1/2 equals 3 over 6. Okay, so let's solve these out. So the first one, I have 8 over x equals 1 over 2. So I'm going to say 8 times 2 equals 1 times x. Okay. So let's think about why we're doing this. If I had 8 over x equals 1 over 2 and I wanted to solve this out, basically I take the x, and since I'm dividing it, I would multiply it to the other side, right? You don't have to write this. So I'd get 8 equals 1 over 2 times x. And then if I want to get the x by itself, I have to get rid of this 2, so I multiply it to the other side. We're just doing both of those steps in one step. We're taking care of both of them at once. So we multiply the denominator over, we multiply the other denominator over. All right, so I get 8 times 2 equals 1 times x, so I have 16 equals x. This one I have 5 times y equals 1 times y plus 4, which is still just y plus 4. So I get 4y equals 4, so y equals 1. And the last one is a little bit harder, so I have 10, and then I want to put parentheses times x plus 1 equals 4 times 4x. So I have 10x plus 10 equals 16x. So subtract the 10x over, I get 6x equals 10. And divide by 6, so I have 10 over 6 equals x. So do I leave it like that? Yeah, I can reduce that, right? So divide by 2 on the top and the bottom, so I get 5 over 3 would be the answer. And I would just leave it as that fraction. Okay, does this make sense? Okay. Okay, so Phidias, an ancient architect and sculptor, created Athena Parthenos. Has anybody ever seen this? Well, you can't really see the original anymore. Has anybody seen this in Nashville? This is what this problem talks about. Has anybody gone down to Nashville, Tennessee and seen this? It's huge. Okay, so he created this around 438 BC. So Athena Parthenos was made of gold and ivory, and it was housed inside the Parthenon in Greece. Unfortunately, the statue was lost in the 15th century, most likely to fire. On the left is a modern reconstruction of the statue, which is in Nashville. It said that Nike, the goddess of victory, I think they actually say Nike, I don't think they call it Nike, is found in her right hand, which is 6 feet tall. So look at this little picture. So this little thing right here, this little sculpture, you can see in her hand, that's 6 feet tall. Doesn't look 6 feet tall, does it? Yeah, it's huge. So the ratio of Nike to Athena is 3 to 19. So how tall is the statue of Athena Parthenos in feet and inches? I think it ends up just being feet, but. All right, so we're going to say 3 to 19 is equal to 6 to x. So this is the scale, was 3 to 19. And these are the actual sizes. Okay, and then on top we had Nike, and on bottom we had Athena. So we want to set it up, Nike over Athena equals Nike over Athena. Okay, so all we do is we just cross multiply. Now some of you guys, like I said, will be very good at doing these things without using a calculator. So I want you to outsmart the system. I don't want you to do everything in a complicated way. Now I could multiply this, cross multiply, and I could say that 3x equals 19 times 6. And you can find 19 times 6 and do 114. And then you can take 114 divided by 3. But what I'm telling you is there's an easier way. So if you get really good at ratios, you'll see this. Any guesses on what this x is? Yeah, it's 38. Sarah says 38. Do you see how she got it? Because we're saying 3 times 2 is what gives us 6. So I'm also going to have to multiply the bottom by 2. It's like reducing fractions but going in reverse. It's like making fractions into the bigger version. So x would have to equal 38. So that's why I was like, oh, it's just feet. It's not feet and inches. So she's 38 feet tall, which is taller than this building. It's very tall. All right, quick break. Oh, I guess I have a couple here. Let's do these last ones. So let's skip number 5, but let's go down to number 6. So it says solve the equations. You might need to factor or use the quadratic formula. So I'm not going to make things easy on you all the time. So you might have things where you have to use the quadratic formula. Do you remember the quadratic formula? Try to write it on your paper. So x equals, write it down. See if you remember it. Don't say it out loud. Do you all know the quadratic formula? So write it down. Starts with a negative b plus or minus the square root of b squared minus 4ac all over 2a. Did you guys get it right? A lot of people forget like the 4ac, they'll write like 4ab or something. Or the negative out front. Okay, so that's our quadratic formula, so we gotta know that. So let's try this. So it says I have x minus 4 times x plus 1 equals 2 times 2x minus 7. So all I'm doing right now is I'm cross multiplying. So I'm taking those two times each other equals these two times each other. So as I start solving it out, I get x squared. My outer is x times 1, so x. My inner is negative 4 times x, so minus 4x. And my last is negative 4 times 1, which is negative 4. And then over here, I just distribute, so I get 4x minus 14. You guys kind of remember this from algebra. Okay, so we start combining like terms. So I'm like, okay, I have x squared minus 3x minus 4 equals 4x minus 14. And I see that I have an equation that has both x's and x squared. So when I have that, it means I either have to factor or I have to use the quadratic formula. Sometimes you can factor, sometimes you can't. So I'm going to subtract the 4x over. So I have x squared minus 7x, right, when I join it. So negative 3x minus 4x. And then I'm going to add the 14, so I have plus 10. So if you can factor it, that's usually easier. I know some of you guys hate factoring that. So what do we get? So we have x minus 2, x minus 5. Do you guys see that? We wanted things that multiply to be the 10, and then when we take our outer and inner swoops, so I always talk about the swoops, I never say multiplies to be 10 and adds to be negative 7, because I think that's confusing. It's these swoops here that make that negative 7x, right? So negative 2x minus 5x. So we get two answers. What are our two answers? 5 and 2. Remember, we set each of those equal to 0. So we get 5 and 2. Yeah, do you have a question? Having trouble with the factoring? Yeah, you can check. So if we go back and we plug in, so if I plug in 5, I get 1 over 2. And I plug in 5, I get 10 minus 7 is 3 over 6. So that one works. And then if I try 2, I get a negative, but that's probably okay still. So if I get a negative, I have negative 2 over 2, which is negative 1. And then I get negative 3 over 3, which is also negative 1. So it works out. Okay, does it make sense? Okay, let's do the next one, but instead of factoring, let's use the quadratic formula, just to see if you guys remember how to do that. Okay, so go ahead and cross multiply, so go ahead and start it out, and then try to solve it using the quadratic formula. I'll give you a second to try it. Cross multiply, you should get 16x equals, and then you're going to have to FOIL out the 2x plus 1 times 6x minus 3. And when you do, you get 12x squared. The outer becomes negative 6x. The inner is plus 6x. And the last is minus 3. Did you guys all have that? A lot of things people will do is they'll mess up like the 12x squared. They'll just put 12x, and then they'll combine all the x's together. So make sure when you do the 2x times 6x, it's 12x squared. All right, so we continue to combine, and then negative 6x and 6x go away. But we still have the 16x over here. So we're going to have 0 equals 12x squared, and we're subtracting that 16x over to the right-hand side. So I'm going to have minus 16x minus 3. Okay, so you can factor this one. It does factor, so you can try it. But it's a little bit tricky because we have 12x squared out front, so we could have like 2x and 3x. We could have, or not 2x and 3x, 2x and 6x, or 3x and 4x, or 12x and 1x, right? How comfortable are you guys with that kind of stuff? Not very comfortable. So you're going to be doing that again in Algebra 2. So we'll do it in class, but you're going to do it again when you get to Algebra 2. So you could factor it, or you can use this quadratic formula. So I told you on this one, let's go ahead and try using the quadratic formula. So we're going to have x is equal to negative b plus or minus the square root of. So we need to identify what a is, what b is, and what c is. So a is the number in front of the x squared, so it's 12. B is the number in front of x, it's negative 16, and c is negative 3. So when we do this, we have negative b, so negative 16 is 16, plus or minus the square root of b squared. So 16, or negative 16, when I square it, becomes 256. It's always positive there, because the negative's being squared as well. Minus 4 times 12 times negative 3, all over 2 times 12. So we get 16 plus or minus the square root of 256 minus 4 times 12 times negative 3. So I'm going to do 4 times 12 times 3. And when I have a negative times a negative, it's going to be a positive. So I have 144 added to 256. So I get 400 under there. And then I have 24. Do you guys know the square root of 400? 20. So we get 16 plus or minus 20 over 24. And then this is the tricky part. So you have to add them together first and then divide by 24, or subtract them and divide by 24. So we're going to do both. So when I do the 16 plus 20, then hit enter, and then divide by 24, I get 1.5. So if I change it to a fraction, I'm going to get 3 over 2. And then the other one, 16 minus 20, is negative 4, divided by 24, reduces down to negative 1 over 6, right? So those are our two answers. So basically, if we had factored this one, I think it works out so that it's like a 6x and a 2x. And then we want the last things to multiply to be 3. But the thing I always tell my Algebra 2 students is you can't put the 3 here. I can't have a 3. I can't have anything that goes into 6 there. Right, do you guys see why? Because in the original I didn't have a GCF. I didn't have like a 3 I could pull out from all of them. So that's kind of a trick with factoring. If you see that you can't put the 3 there because there'd be a GCF, you can only put the 1 there and then you put a 3 here. And then when you look at your outer and inner swoops, you have 2x and you have 18x. You want them to combine to be negative 16, right? So we do a negative with the 18 and a positive with the 2. So it's negative here and positive here. And then we get those same answers. So it works with factoring, but maybe it's a little bit easier for you guys at this point in time to do the quadratic formula. It's up to you guys. Okay.